Thank you. Audio and video is quite clear, right?
Fine, sir.
Fine. So should I wait for the participants to join, or I can start now?
Sir, they are watching you, sir, in YouTube, sir.
Okay, fine. Audio and video is quite clear, right? So dear students, teachers and industry practitioners, as we see this course, you must have noticed it is one only course which is there in India, which is in this subject, that is collaborative robot. Although this is a very upcoming subject which is going to take over industry very soon. So you have already witnessed the quadruped robots and humanoid robots are coming up.
Sir, pardon, sir.
Yes,
Sir,
yes.
please mute your YouTube, sir. YouTube audio, sir.
Yeah, I have muted already. It's muted.
Uh,
I'll close it also. No, YouTube for
okay,
me
okay.
is not required. I have closed it. So is it giving any echo there or what?
Now fine, sir. Please
Now
continue.
fine, I have closed my YouTube audio.
Okay, okay.
Okay, so dear participants, so all students, teachers and industry practitioners, as you have witnessed, this course is unique because it is the only course which is in MOOC channel anywhere across India and abroad also. Only in Coursera there is a one, but yes, this is highly technical, covering all the grassroots level things which should be there for this subject. Okay, so you see, there are quadrupeds, there are humanoids, there are many types of robots which is taking up these days, which is a kind of learning robots. So they all have their limbs, appendages, body parts. They are all working on this technology that we are going to that we are covering in this course, that is cobotics. Okay, so industry will be flooded very soon by next 5 or 10 years. You will see almost industries will replace almost all the low payload capacity robot by cobot, because it is a human robot collaboration that is there. Okay, so that is why this course finds its place, and hopefully I'll just share my course content. I'll discuss one after the other after that. Okay, so when you say this, we have covered. I introduced you to cobot, what exactly it is. You must have found some similarity with the type of robots that you have seen quite a lot of places. Even humanoids, their arms are like cobot, their legs are cobots, right? So even the legs are armed. In case of, in general, robot, they are also armed. So they are body appendages. Okay, so I showed you quite incident report which stresses upon the need of cobots in the industry, because you saw there are lot many accidents even in India. You must have noticed. I have shared some news reporting from India also. Okay, you saw huge number of applications which normal robot, industrial robot cannot do, which can be done by cobots. Okay, especially AI adaptive robots and all. Collaborative modes I have explained as per ISO standard. How does it look like? So I discussed over quite a lot of industrial standards which actually should be looked at when you buy a cobot or use any robot, any cobot especially. Okay, there are standards like ISO 9283 and all were quite standard, which was there in industrial robots. But when you deal with cobots, there are many other industrial standards which should be there when you take up any cobots. Why? Because Industry is flooded with cobot markets. Looking at that, quite a lot of fake cobots are also there. So be very careful while you use one of them in your lab, okay, because that makes you potentially very unsafe. Okay, so your students may get injured, and it is very, very dangerous. So it is not that once in a while we do it and we can take care, but it is very, we are dealing with the students, so it is very, very important to take care of your students. So if it is a cobot, it has to be cobot. It cannot be just claimed cobot. So that difference I have taught, how the current sensing based technologies are there, pure torque sensing based joints are there, which are making it a cobot. Different collaborative robot standards I have discussed, various ISO standards I have discussed. That is very, very important. You look at them very, very carefully. Okay, not just as a subject, as an application engineer, you need to be very careful. I have covered task-based risk assessment methodology in the first week itself. That is how industry people should be aware of how risk assessment is done for any machine in general. But yes, for cobots and robots in place also, you can do it. Okay, standard performance levels. That is, if it is applied with medical or entertainment or any kind of industry, how you should take care. What is the concept of compliance you have discussed? Okay, so yes, and fundamental technological difference. What is a robot? What is a cobot? You have appeared for your quiz already, weekly assignments. Hope these are quite okay with you. You have digested well, looking at the performance and all. Force control, how it has evolved, how we have reached till cobots, who are the major makers. I have discussed on various parameters. So these are few enlightenment which should be there when you deal with cobots. How technology transition has happened, difference between controller design. Controller itself is quite different. Okay, you have to deal with joint torque control. Earlier it was position control. Now you know already. Associated hardware changes, why the cost goes so high. Okay, cobot system design, what are the components, okay, edges, body, what are the regulations which are there. Okay, so these things were covered in week 1 itself, which has enlightened you to a quite high level that you can at least now distinguish between a cobot and a robot, industrial robot. Constrained workspace, it is not covered in quite a lot of test books also, but I have attempted to cover it to make it very clear how robots should be applied for a particular application. So constraint. So this course as a whole is a vision of myself, and it should be there about almost when I started my PhD in 2010, the cobot already started taking up the place. We have, so 2010 to 2025 now. So almost, you see, so many years passed by, and we are still doing too much of fundamentals, and still no courses are there, and very few books are there, and mostly are in research. Not even a single textbook is there. So you see, the course justifies itself by such need. You see, it is almost around, you see, it was 10 years before me also. Even Osama Khatib and all, they started almost 20-30 years back, they started publishing in cobalt. So you saw that through timeline of cobalt, it's a history now, but still it is not very popular. But now it has come up because of its popularity in humanoid robots and quadruped robots at least. Okay, now it is taking up industrial spaces due to lack of literacy, kind of. Not just in India, it is in abroad also. Very few institutes are covering this because it is mostly too much of research that went in, which has actually made this standard robot a cobot. So that is the reason it was covered to this detail in the introduction itself. Okay, so introduction itself will make you aware of why the importance of this course. Okay, so second week you learnt about actuators. I have covered actuators even in my another NPTEL course, that is on industrial robots, theories for implementation. That is normally run in the June session of NPTEL SWAYAM portal. So that one was different, and this is little different in the way I have covered BLDC motor much more in detail, and the kind of motor drives, especially those who can do torque control. I have covered them in very much detail. Harmonic drives I have covered. Okay, that is special to cobots only. Although quite a lot of contents are overlapping, but yes, I have focused more upon, and also I have exempted few kinds of actuators which were there in a standard robotics course like stepper motor or a DC motor kind of designs. So that I have excluded here totally, at least stepper motor. I have covered more in detail the kind of actuators which are there in cobots. So mostly this course is for design of cobots. As an application engineer, you should be aware of what is there in the design of such cobots also. Transformation matrices and forward kinematics, it is similar to standard industrial robot, but yes, I have covered forward kinematics of 7 DOF arm, that is KUKA IVA, and 6 DOF, which is one of the most popular universal robots arm. So that is I have covered in this course. So that is forward kinematics. Again, it is little bit unique as compared to previous course, but the procedures are all same. So it must be quite easy going for those who have done robotics course earlier. I think currently we have done just finished inverse kinematics over there in the SWAYAM portal for this course. Inverse kinematics doing is very, very trivial as long as it is in first week, first lecture that I have covered. After that, I have used UR5 manipulator, again, a very popular robot for which inverse kinematics was covered in this course. Okay. KUKA LBR IVA was covered. That's a unique methodology which was covered. Demonstration of null space we have done, which is unique to 7 degree of freedom robots and cobots. So those things are new to this course, which is not there in textbook also. Differential motion analysis, that is there, that is common. So those fundamentals will help you to understand week 8, that is force control, that we are going to cover. Okay, so the remaining things which are there, so we will prepare you for the upcoming weeks which are there. Statics, you saw how gravity compensation helps you to create robot arm which are which is supporting lead through programming. Okay, so those things will be covered. That is the ongoing week. This is week 5. Okay, so remaining few things are very, very common which are there, but yes, you should focus on force ellipsoid, velocity ellipsoid. This will help you to understand the forces and velocity workspaces of standard robot or a cobot in general. Statics plays a lot of role in case of cobots because cobots deal with quasi-static tasks most of the time. So while you do interaction tasks or human collaboration tasks, it remains in this zone only. So dynamics comes when the robot moves at a high speed, but at very slow speed, slow interaction, statics plays a vital role. So be very, very focused in this module. So this is my suggestion and my comments on what was covered so far. I would like to hear from you all. If you have any queries, you can get in now. Yes, I am waiting. If it is there, please forward. My TAs are here. Mr. Himanshu is here. Mr. Asis is here. They are exceptional students who are trained on cobots now. They are my PhD students. Okay, you. I hope you are getting answered in the forums also. Is it not? Himanshu is taking care of that. Asis is busy doing his final thesis and he is involved in preparing quizzes and all for you all. That is assignment and all. So yes. So in future, maybe you can communicate to my TAs also. They are well trained on cobots now. Okay. That is Himanshu and Ashish Siddharth. Hope you have their email now already. You can personally connect to them, taking any suggestions. They are very helpful. Okay, so far this is covered. So modules which are going to come are Week 6, that is dynamics. Again, we have covered quite a lot here. Lagrange-Euler, Newton-Euler, recursive formulation for Newton-Euler we have covered. We have exempted DNOC here, but yes, that will be covered in later run of this course maybe. Robot control, you focus on this, that will come. Force control is very, very important. That is unique to cobots only. Okay, it is an application of cobot which actually goes. So that is going to come in week 8. That is unique, and it is not all parts are there in almost all the textbooks which are there in cobots or robots. Okay. So yes, any questions if it has come? If not, we'll wait for another 4 or 5 minutes and we'll stop there. Others can directly go to the link and see my message here later also. It will remain on YouTube here. So we'll wait for another 5 minutes and we'll quit. So I think there are no queries as such. Nobody has joined online, but no issue. They can always refer to my message which I have posted here just now on YouTube. So I think I can quit.
Yes, sir.
Okay,
Ye-
then thanks a lot. Best wishes for the upcoming weeks. We'll see you later in the second session of live. Okay, that's all. Thanks a lot.